Hello and welcome to today's talk about container as a service at Telia. My name is Jonathan Kyrklund and I'm an IT consultant at Forefront Consulting Group. My background is as a developer, which I studied at Linköping University. But as fate had it, I ended up working with enterprise IT, mainly because I realized I could get paid doing something I enjoy doing as a hobby, mainly fixing computers. As I advanced, I started working with architecting and implementing complete systems such as Active Directory, Direct Access, ADFS, and other complex systems on-prem. As cloud made its introduction, I started migrating towards hybrid cloud solutions and soon came into contact with developers and the open source community. Since January, I've been working at Telia, helping them implement their container as a service solution. So the problem of why, as some of you might have heard, there's something called secret sprawl, but that's another topic for another day, but it connects to what Telia was facing. Telia is facing something called Kubernetes sprawl, as I like to call it. They have multiple clusters spread across different teams and different countries, and sometimes even developers have created their own clusters, which meant they have to deal with day two operations and compliance instead of creating a direct value to the company. There's also the problem of confusion with multiple clusters, because how do you choose where to deploy your service? Which is the correct one? Which is the way Telia wants to do it? So the solution to all this, since Telia has their own internal self-service portal, where they can order virtual machines, databases, and many different other services. The obvious choice is to create container as a service. And the benefits of that is, of course, that they will be accelerating their time to market via the self-service portal. They will also increase the efficiency by leveraging automation. It also removes the operational burden of the day two operations from the developers, and also finally a unified way to deploy services. So what then? As there's multiple solutions for container orchestrations on the market today, Telia decided to create a project team with the objective to find the best solutions. I won't go into too much detail as this is prior to my time at Telia, but I will show you the three options that Telia was evaluating. And the winner is, no surprise, Rancher, which they choose to continue with. So the how then? We decided to stick with two core principles. The first one is infrastructure as code, which we decided is a must. And the second one is GitOps, where we're using Git as a source of truth, but also working towards having a commit to production workflow. And the design that we decided to build was kind of like the TV chefs, where we used Packer to create images and template containing sys hardening and other softwares that we wanted in production. And the next step was that we had Terraform, which we used to provision virtual machines, and Trident and Rancher Kubernetes engine. While working with Terraform, we also noticed that we need to use a modular way of work, since we were multiple developers working with the same code base. And lastly, we used Ansible to stitch it all together and use it as kind of like a glue, and also orchestrating the deployments of the different environments. And the future then, we're aiming towards bringing the production into the platform in this autumn. And in the far future, we also see that we hope to get the platform into a matured state where we actually can give the keys to the developers so they can self-provision clusters, like creating a development cluster all by themselves and also tearing it down when they're finished with it. And the lessons learned along the way. First, we noticed that VMware is not and never a first-class citizen in the open source community, sadly. Most of the open source product, they presume that you're in AWS or in Azure. There's also the second good thing is having really good knowledge of Kubernetes, especially of the internal engines running within Kubernetes. And getting production ready always takes more time than estimated. Scoping out what should be included in the container as a service is also difficult. We notice that we are constantly struggling with deciding what features we should include and what we should exclude. Should we offer an ELK stack? Should we offer the developers pre-made pipeline, or should they bring them themselves? There was also a confusion which myself was struggling with, and it's the Terraform Rancher provider versus the community RKE provider. I mixed them up plenty of times before I realized or understood the difference between the two. And lastly, infrastructure as code rules. As we noticed as time went by, we ended up daily redeploying the environments and clusters almost constantly. So for the demo part, there's going to be some differences. Since there might be sensitive information, I decided to create everything from scratch and deploying to Azure instead. So the main differences is that it's not going to be in Telia's VMware environment, and I'm skipping Packer and Ansible to keep it more simple. So the plan for the demo is that first I'm going to create a couple of virtual machines in Azure using Terraform. Then on those newly created machines, I'm going to create a Kubernetes cluster using the RKE or Rancher Kubernetes engine. And the next step after that is that I'm going to spin up Rancher on that Kubernetes cluster. And after that, log in to the newly created Rancher GUI, and then go into the cluster feature and create a new worker cluster hosted in Azure.
One of the key benefits of working with infrastructure as code is, of course, that you can leverage the strength of a version control system. So when you're using a Git, you can, for example, use GitHub to store all your code that you're currently working with. So in this case, I created a repository over at GitHub, and I'm going to start off by cloning it down to my local machine. As such, and then we go into the Rancher folder, and we can start Visual Studio Code to get a better look at what the code looks like. So in this case, we have two files in the root of the folder. One is called main.tf and the other one is providers.tf. What Terraform does is it's going to merge all the Terraform files at the current directory together and handle them all at the same time. But for ease of read and easier to find different resources, I've decided to separate them. So I keep all the providers in one specific place. And a provider then. Terraform uses providers as a means to interact with other external system. So there's so many different providers. You even have one for Domino's Pizzas, for example. But in our case, the first part, we're going to be using one called Azure RM. And that's a provider used when interacting with Azure to create resources or just get information out of Azure. And in order to get all the providers that we need to run a command as well. So I'm going to run Terraform init. What it's actually doing is looking at the providers that you have specified, and also within your code, if you have used any modules, it's going to download the modules that you have referenced, and it's going to download all the providers that you don't have downloaded at the present time when you run Terraform init. So as you can see in this example, it's looking at quite a lot of different providers. We use one for Rancher RKE, And we use one specific called Rancher 2. That's one for interacting with Rancher. And we have the Azure RM provider, but we're also going to be using Helm, Kubernetes, and TLS. And the null provider is used for creating null resources, which I'm going to go through a bit further on in the demo. And here we can see them installing all the different providers that we have specified. And so we have finally initialized this repository and downloaded all the providers that we need. So if we want to see what the Terraform code is planning on doing, we can run a command called Terraform plan. What it's doing then is going to pick this main TF file, and it's going to check all these different modules and go in each and every one of them. And for ease, I have gathered all the different modules in this same repository, but a module can also be a distant Git repository or a Bitbucket repository, as you can source them in. But in order to just see quite quickly, we can see that the first part is going to be a module called Rancher VMs. And this is pointing towards the folder Azure VMS, which is this folder over here. So if we go into this one, we have a similar layout with multiple Terraform files. And we have the main Terraform file, and we have an output, and we also have variables, which is, like I said, only to make it easier to find specific parts of Terraform. And for the first part of the demo, we're going to be creating a couple of virtual machines. So we can start off by commenting out the RKE installer and the Rancher installer, just to see all the steps by themselves. Such. And if we look here, earlier it wanted to create 42 new resources. And if we do the same plan again, when we have commented out the two other modules, we're going to see a lot fewer resources being asked to be created. As such, we only have 31 resources that Terraform wants to apply now. So if we go ahead and run a Terraform apply, you can see it's going to do the same plan again, refreshing the current state of the Azure environment, comparing it towards its internal Terraform state, and against the code base as well, to see what the difference is. Since we're working against a clean environment, everything is going to be created from scratch. So we go ahead and say yes, and let Terraform start off by creating the resources that we want. So we can look at the main Terraform file here, which is the one being used at the moment. So at the beginning here, we're going to be creating a resource group in Azure, since in Azure, everything needs to be residing within a resource group. And the next step is creating a virtual network. For this demo, I've specified a serial network of /23. And it's going to be residing in the same location and resource group as we created earlier. And specifying a different resource within Terraform this way, as we're pointing out here, that we are going to be using the Azure resource group called RG, which is this one above here, makes it so that Terraform knows in what order it needs to be creating all the different resources. And after the VNet, we're going to be creating a subnet, which is dependent also on the VNet being in place at first. And next, we're going to be creating 3 public virtual IPs and put them also in the same resource group. And those IPs that we have created it's going to need some security as well. So we're going to be creating a network security group. And we're going to specify that we're going to be using this Sideroscope, which is the Telia VPN network, which I'm residing on right now, just in order to keep things a bit safer for the virtual machines. Then we're going to be creating 3 virtual network cards using this count method, and the names is going to be dependent on what order they are being created. And we're going to bind those with the IP configuration to the subnet that we created, getting a dynamic IP address on the private IP, but also adding the respective public IP. So our virtual machines are going to be having 2 IPs. Then we connect the network interface card to the network security group that we have both created to make sure that the machines are safe behind the network security group. And the next step is working with the load balancer. The load balancer is going to be used in order to access Rancher once it's up and running. So we're going to be creating a we're going to be creating a public IP for the load balancer, and which is going to be used at the front end. And we're going to create also a backend pool where we add all the virtual machines that we have created. So the virtual machines are going to be residing behind the load balancer. Then we need a probe as well for the load balancer to know what virtual machines are actually ready to take traffic. And we create a rule binding the port 443 on the front end of the load balancer to the port 443 on the back end. And also using the probe and the backend pool. And next we're creating virtual disks, since the machines themselves need some disks to store their data. And for this demo, I'm being lazy as well and using Terraform to actually create the RSA keys. So we can use them to handle the access and the interaction with the virtual machines that we're creating. And we're also going to add all the virtual machines to an availability set in order to make sure that we can keep them up and separate from each other, so they don't get hit by patches and updates that Azure And next we have the actual part that matters, which is the creation of the virtual machines themselves. And we want 3 virtual machines, which I have specified in the variable file here. And then we specify an admin password, but we're going to disable the admin password, so this password doesn't really do anything, but it's good to have it in place. But yeah, that's pretty much it. So we can have a look now at the code to see how it's progressing. And we can see it has actually completed all the virtual machines that we decided. Quite fast as well. And if we go into the Azure portal, we can do a refresh here and see that the resource group has been created here. And if we go into this resource group, we can see that we have the availability set, the 3 virtual disks, the load balancers, the network interface, and the public IPs, 4 of them, 3 for the virtual machines and 1 for the load balancer itself. And we have the network security group and the VNet as well. And if we check via the VNet, we can actually do a quick overview through the diagram here and see how our current setup is looking. And for the next step, now that we have our virtual machines up and running, we're going to be creating a Kubernetes cluster using the RKE binary. So we can go back into our code base and first off, start off by uncommenting the RKE install module. If we then do a Terraform plan, we should be able to see what kind of resources are Terraform wants to add or create with this new module that we've added. First off, it's doing a refresh of the previous module, verifying that no changes has been made to our virtual machines. So it looks good, no changes on the virtual machines. Soon we will see the kind of changes that Terraform wants to do to our environment. So it wants to add 5 new resources. We can start from the top. Yeah, the first one is the kube cluster YAML file, which is going to be created after we have created our Kubernetes cluster. And then we have 3 resources, which is actually just a null resource and used to test the SSH. And then we have the actual RKE Kubernetes cluster that's going to be created, and all the data of the nodes that we have created. So we can go ahead and do a Terraform apply, and just because I'm lazy, I'm going to type auto approve, so I don't have to type yes at the end of the apply, since we've already gone through the plan here. Sometimes there can be differences between a plan and apply, so it's better to use auto approve with caution, unless you know it's going to go through smoothly. So we can look at the RKE installer module and see what it's actually doing. So we can expand this one, and we have here 3 files in this case. We have the variables containing all the different variables that can be used within the module. Then we have the output, what the module is going to be exporting. And we want to export the kube config so we can interact with our newly created Kubernetes cluster once we're done with it. And in the main file here, we start off by specifying that we have a specific required provider, which is a third party, but it's residing, like I said earlier, in the Terraform registry. And the next step is the actual SSH test. So when you create virtual machines and then you call this module quite fast afterwards, there are some cases when the SSH isn't up and running yet, or the Docker socket isn't ready to receive. So what I'm doing here is just verifying that that I can connect to all the virtual machines before the actual RKE cluster starts to be created. Yeah, we've noticed some cases that the RKE cluster, when you're using this RKE to install it and with Terraform, it actually tries only once, and if it fails, it stops immediately. It doesn't continue to try. That's why we implemented the SSH test prior to it. And the information that the RKE cluster demands is a cluster name and a Kubernetes version, and of course some nodes. And in this case, we're going to be using the dynamic block, so we have the possibility to add multiple or as many as we need. And we're going to be using the for each and iterate through all the different nodes that we send in. And since we're creating a management cluster, we're going to set the control plane, the etcd, and the worker role on all our virtual machines. And we specify that we want the ranch user and the SSH key that we send in when we're calling the RKE installer. Down here we have some life cycle changes that we want to ignore. So why we're doing this is because if the state or the kube config changes, we don't want Terraform to believe it has to recreate this entire cluster. So that's just for future or day 2 operations. And lastly, we create a local file and output the kube config so we can manually use it to interact with our Kubernetes cluster once it's created. And we can go back and see the progress of the the installation. We can see that it's starting off with the SSH test, and it can connect to all the virtual machines, specifying that the SSH socket is ready, and it continues then to creating the RKE Kubernetes cluster. And we can get back once the cluster is ready. Now that the RKE has finished, we can see it has added the 5 resources that we decided, and it took approximately 7 minutes and 38 seconds to create a Kubernetes cluster using the RKE provider. And if we want, we can actually verify that we can connect to our Kubernetes clusters. So we take up a new terminal and do a kubectl. So I can kubectl. More easier to see. I have an alias for a kubectl specified to just k. So kubectl and the kubeconfig, and we're pointing towards the kubeconfig file that we got created. And we request to get all the namespaces in the Kubernetes clusters. And we can see that it has created a default namespace, an ingress nginx, and 3 more that Kube is using. So we basically have a Kubernetes cluster up and running. So for the next part of the demo, we have the actual rancher installed onto our newly created Kubernetes cluster. So once again, we're going to do the same thing. We're going to uncomment this part and add it to our cluster. So we do a Terraform plan to see that what Terraform wants to add this time. And the input to this one is the kubeconfig and the server that we connect to when we want to install our rancher. So once again, it's going to do a refresh. This time it's going to refresh and verify that the virtual machines are correct, and also that the RKE is in a desired state. We can see soon it should be spitting out. Yeah, here we have 6 new resources to be added. And we have the cert manager, which is a Helm release, and we have the rancher Helm release, and we have a namespace for rancher and for cert manager, wait, and then we also have a bootstrap. So we can go ahead and do Terraform apply again. Last time, and we can go back to the code base to see what the actual rancher installer is doing. So here again we have 3 Terraform files, one with variables and one with the providers that we're going to be used. And here we have the bootstrap scenario where we want to initiate the rancher. And we also have the main file, which is what's going to be running. Since rancher needs cert manager to be installed in the Kubernetes cluster in order to function, we're going to start off by creating a namespace. And for that, we use the Kubernetes provider to create a cert manager namespace. And here at the same time, we make sure that Terraform doesn't want to change the cert manager namespace every single time, since rancher and Kubernetes make some minor changes to the metadata. Then we have a Helm release. So we're going to use Helm in order to install cert manager onto our Kubernetes cluster. And here we can also see the depends on block. What this is since there is no normal, how to say, dependency between these two, the namespace and the Helm release, we have to create an explicit dependency between the two. So it's specifying what kind of repository or where the repository is and what shard we're going to be using. And we can also set the different values that exist in the Helm value shard. Then we go on to the Kubernetes Rancher, the Rancher namespace. So it's called cattle system. And at the same time, we ignore life cycle changes. And at last, we're going to be installing the Rancher using Helm as well. And at the bottom here, we have a null resource again, but as we're waiting for the URL or Rancher GUI to come up. And last, when the GUI is up and running, we're gonna initiate the bootstrapping process of the Rancher cluster. Head back and see how the code. This happens from time to time, but if we do a Terraform apply and auto approve again, hopefully it's going to go through smoothly this time. And continue with the creation of the installation of Rancher. Let's see. Okay, do we have anything? Modular Rancher VMs. Do we have anything that's been created yet from the Rancher installed? Yeah, we have the namespace. Seems to be have created. Yeah, it was just the Rancher Helm install that apparently got stuck on some way. But sometimes it's just to rerun Terraform to see. If you get the same error again, then it's persistent and you have to debug and see what's causing it. Sometimes it's just the Docker socket that hasn't come up yet, or it could be that the load on the virtual machines is too high at the moment. So, but right now it's looking good, and it's continuing with the creation of or installation of Rancher onto our Kubernetes cluster. And when that is ready, I can get back and we can look further into the Rancher GUI. Now that Terraform has finished the installation of Rancher onto our Kubernetes cluster, we can proceed with the next step, which is to actually log in to our Rancher GUI. Here in the Rancher Helm chart, we have specified a host name, which is also going to be used as the URL to log in to our Rancher GUI. And on the side, I have also created a DNS record for this specific URL, which is going to be pointing towards the IP address of the front-end load balancer. So if we proceed then to browse to this URL, we're going to be seeing that we connect to the login interface of the Rancher management. Since this is a proof of concept and a demo, I have not created or supplied any specific certificates. So Rancher is going to use Cert Manager to create one for itself. And the admin password is something that we have specified here when we bootstrap the Rancher environment. So I'm gonna copy paste this one and insert it here so we can log in. And here we see the cluster interface within the Rancher management. And we can look at the local cluster, for example, which is the management cluster. Here we have some information about how the cluster is health is currently at, and we can also get more information about each respective node. Since the management cluster isn't going to be handling any loads or work, we have previously assigned all the roles to each of the nodes. So then we can continue with the next step, which is to actually create a new cluster. And we go over here to cluster and click add cluster. Here we can see that there's multiple providers which can be used in order to create worker nodes across the different platforms. And for the purpose of this demo, I'm going to be using the Azure AKS, which is hand managed by Azure Kubernetes environment. So first off, we're gonna define a name for our cluster. Let's call it Rancher Worker 1. That's the name for our cluster. And here we need to supply some information about our Azure connection. So I'm gonna go here and fetch the subscription ID, which is residing here. And we can go over and collect the tenant. For the demo, I'm using Forefront's tenant and the application ID, which is the same as the client ID, and a client secret as well. Let's see, this is the password. And we're gonna select a different region, which is closer to us. Let's go with West Europe for this one. And then we can click next and continue to the next step, where we're actually going to specify some information about the cluster that we want to create. Here we can decide what Kubernetes version we want. So let's stick with the latest one. And I'm going to leave a lot of the configuration and setting to a default. This part here is the resource group we want the cluster to be deployed to. So in order to have the service principal being able to create the cluster, it needs to have a resource group that's pre-existing, and it also needs the permission. So you need to run this command in order to assign permission to a specific resource. So we're gonna add that resource group, and we want 3 nodes. I'm gonna stick with the standard VM size and default networking. And for the public SSH key, I'm gonna just pick my personal one from, let's see. And it's the public one that we want. As such. Then we click create, and we'll be seeing that it starts the provision process. So this is going to take some time, so I'm gonna leave it at this, and we'll get right back once the provisioning has finished. The cluster has now been provisioned and is ready. So we can see that it's turned from provisioning to an active state. And whilst checking that, we can also go through the authentication. In Rancher, you can use multiple authentication providers. So for example, if you want to use Active Directory, you can use that in order to decide what users should be, or how do you want to handle the credentials. And then we can go over to users. Right now we only have one user, which is the admin user, but it's possible to create local users as well, and give them different specific permissions, what they're allowed to do, and give them access to one specific project or cluster, or multiple clusters for that part as well. But one key thing is that once you have a user and you have a worker cluster, and the users actually want to deploy something, it's going to be using the kubeconfig file, which you can find on this page. And the beautiful thing with this one is that all the authentication is going to be handled, or also the ACL and Airbag is going to be handled by Rancher. So if you're using this kubeconfig file, you're gonna go past the load balancer, and then via that down to the clusters. And yeah, so that handles a lot of the authentication parts to different clusters. And once you're ready and you've tested everything, it's also very wise to always remember to clean up the environments which you have created for your proof of concept or development. So in this case, I'm gonna start off by removing the cluster, and at the same time, we can go over to Terraform and do a Terraform destroy in order to remove all the resources that we have created, so we don't have any costs while we're not using the proof of concept or test environment. Thanks for listening, and as there's many more features to look into at Rancher, we're going to hand over the next presentation to Sheldon over at Rancher. Thanks for watching.
Hi everyone, my name is Sheldon and I'm a field engineer at Rancher Labs, and I'll be giving you a more in-depth look at Rancher. I don't have any slides for you other than this one with my face on it, because I basically just, well, there was no point in videotaping myself because I'm just going to jump into the demo anyway. So let's do that right now. So as you can see, I'm currently on the Rancher login page. Here you'll see that I need to log in with my GitHub credentials, and that's because we actually use our GitHub as our central authentication backend. So anyone in our GitHub organization can just use their GitHub credentials to log in. I don't have to add in my credentials because they're already cached, so I can just click on login with GitHub. This is one of our demo sites, so I have set up a bunch of clusters, and my colleagues also have some stuff on here. But as you can see, this is the full list of clusters that are currently running, and this is also the first thing you'll see when you log into Rancher. Here you can see these are the clusters that I have created, the HashiCorp and Rancher event clusters. So I basically named them AWS, Azure, DigitalOcean, and vSphere because, well, those are the ones that I just have my credentials set up for. If I want to use something else, then I need to just first make sure that I get the right credentials to a specific cloud or things like that, right? So I named them AWS, Azure, DigitalOcean, and vSphere, but of course it might be a bit redundant because the provider also lets us know what it is. So these clusters, AWS, just Amazon EC2, Azure, DigitalOcean, etc., right? So these clusters I'm going to use to demo to you today, but as you can see, my other colleagues also have some demos on here that are running. A bunch of vSphere, also some DigitalOcean, even one K3s. So if you don't know what K3s is, that's our lightweight Kubernetes distribution, and we can also import K3s clusters into Rancher. So let's jump into one of the clusters, because you've already seen, hopefully then, how to set up Rancher and how you can then create a cluster after that's been set up. So let me jump into one to show you a bit further into how the clusters work. So if I click on my cluster, you'll see that you get a bunch of information, right? So some metrics, not that much. You can see what's reserved and the pods that are used. Well, used is kind of strange maybe because just out of the 110 spots available, basically 9 spots have been used for the pods, or at least 9 pods out of 110 have already been used. This 110 is just a number you can set during the creation of the cluster. Is just a kubelet configuration basically. So if you really need to increase that, you can increase that if necessary. However, like I said, nothing special here, just some basic metrics. But with these metrics alone, you can already do things like go in and create an alert. So if I want to create an alert group, for example, I can just go in, give it a name, select what type of, well, in this instance, system service, or what type of resource, or type of node, and basically any metric I want to, well, any available metric that I want to get an alert on. If I set that, I might get something like there's a high CPU load, or the scheduler is unavailable, or things like that. And with this alert, that's all fine, of course, and then you'll see that in the Ranch UI as well. But what's more important is that you can set a notifier, and a notifier is then going to be perhaps connected to Slack or email, or perhaps even trigger a webhook, right? So you can set an alert and attach a notification to that and get notified when something happens. Of course, like I said, these are just some basic metrics, right? So if you want to get more out of this, which of course we recommend, you can go in, select enable monitoring to see live metrics, or tools and monitoring. It basically brings you to the same spot, right? Tools and monitoring, or enable monitoring to see live metrics. So if I don't have to change anything, you could, if you want, tweak some things like data retention. If you want to use persistent storage, for example, you can. What this does is set up Prometheus and Grafana for you automatically. So if I don't change anything, if I don't want to use persistent storage or whatever I would like to change in these configurations, I can just scroll down, hit enable, and this is then just activated cluster level monitoring for me. So if I were to go to this system namespace, or the system project containing the kube system namespaces and a bunch of other system namespaces, you'll see that the Prometheus resources are being deployed. The same thing for the Grafana resources. So Rancher sets all of this up for you automatically. So this just takes a minute or two, and maybe an extra minute for Prometheus to start getting some metrics, so we can start creating some graphs out of those metrics. Of course, Prometheus does being a time series database that has a bunch of endpoints and metrics you can scrape, and Grafana being the way to visualize those metrics. So if I go back to my cluster, you'll see that monitoring API is not ready, so it's just installing that for me. Once that is up, I could, for example, give it a second, or let me just go to this cluster. This is already up. Here you can see this is what it looks like with live monitoring enabled. So I have, of course, still the reserved amount, but now I can also see things like the actual usage. So of course, with Kubernetes, you can set certain request limits, and of course, those are then reserved and just summed up. But if you, for example, have multiple applications with maybe a high default, you can see that maybe it is too high, basically, because if you're deploying your applications with a minimum resource or CPU or memory limit with, for example, let's say 1 gig or 1.5 gigs or 1 core, then that is going to be reserved for that application, even if it's not going to use it. So if you know exactly what resources your applications need, you can set those limits, right? So the request limit and the actual limit. So Kubernetes kills it if it goes over that limit. Then you could directly, or basically more precisely, define those limits for your application. But if you don't, and maybe some admin just set a default for certain namespaces, then maybe that default is too high, or maybe the default is too low. So your application might be running and Kubernetes is killing your application because it's reaching the default limit set for that namespace. However, then of course you would go and talk to that admin, or just add them to your application themselves, because those will override any default set in a namespace, and then continue on. But with this, you can at least see what the actual usage is, and maybe tweak your request limits moving forward. And of course, maybe it's just the way it is, and you just need this space in case it peaks, so other things don't get killed. So while I was talking, let's see if I go back, if this is already up on this cluster. Well, here you can see it's already active, but we're still missing some information, and that's because it's still gathering that information, right? So if I expand, for example, these cluster metrics, you'll see a bunch of very plain graphs, right? But this is just because it measured over the last minute or something. So if I go back to the AWS cluster, you'll see that I also now have these Grafana icons available, right? So in my cluster metrics, etcd metrics, my nodes, I can click on the icon and it will then open up Grafana for me. So Grafana is going to visualize all these metrics that Prometheus is now scraping, and it will allow us to, of course, look at the metrics, put them on a board somewhere, perhaps put it on a screen in the office, or perhaps maybe even create your own custom dashboards, because you could just sign in and use the Prometheus query language to also create your own queries and your own graphs. But out of the box, you just get a bunch of stuff already pre-created for you. So a bunch of information you can just already start using and leveraging. As you can see, it's all already just populated for you, but you can customize if you like. So if I close this and go back, here you'll see, okay, we have some more information. So you see the reserves, almost half, and then the actual usage is just 9%. And of course, this won't be that spectacular, but maybe some things have changed here, as you can see. Well, that's cool. So as you saw, basically just a click you have to do, and then it just installs Prometheus and Grafana for you. And this works on a cluster level and on a project level as well. So at a project level, you can get specific monitoring metrics as well. But now that we have live metrics also enabled, if we go into alerts and add an alert, now we also have this expression field available, where basically here you can see all of the Prometheus endpoints that we now have available. So these are just whatever you can think of, or whatever Prometheus has available for you to scrape, you can get them from here. And this is now available because you have installed Prometheus. So you get a lot more endpoints to actually get alerts on, and of course to then get attached notifications to, so you can get notified if something happens. Even going as far as saying, hey, I'll add a Prometheus endpoint to my application and then scrape that Prometheus endpoint and then add an alert in Rancher so you can see if anything happens. Going back to the clusters, one thing I also want to do in the meantime, by the way, while I'm talking, I'm going to add a cluster, because you've seen how to simply add a cluster, but there are multiple ways to add clusters, right? So you can add a cluster that consists of existing nodes, or import any existing cluster, right? So for example, that K3S cluster or an RKE cluster or a Cube ADM cluster that you created, you can just import that cluster. As long as it's a CNCF certified Kubernetes distribution, meaning that it's mostly upstream Kubernetes, nothing crazy has been changed in the distro, then you can just easily just import into the Rancher. If you look at, we see these two. If you look at the names here, for example, these are our cloud VMs. So EC2, Azure Compute, DigitalOcean. These are just the VMs in the cloud that we're renting, basically, right? So if you select one of these, you would give it a name. You would create a template, for example, and this template would be basically all of the questions that you have or would get in the cloud, right? You get in your template. So for example, if I want it in EU Central and I want, for example, my own AWS credentials because I've already added them into Rancher, then I can go in and select my VPC, select any security groups. If there are any existing security groups, this is all just going to get populated in Rancher. So if I select my demo group, for example, and here you'll see, just like in the cloud, what type of resource do you want, SSH users, IAM, instance policies, all of those things are just like you would select and choose in the cloud. But now you create a template. When you create it, that template is then saved. As you can see, I already have a bunch of templates, right? I love to name my templates with the resources they have, because it's just easier. I don't tend to remember what a micro is and what a 2XL is, right? So I just give it what it is. 4 CPU, 16 gigs, 8 CPU, 32 gigs, right? So you create it once, and then you can just always use that. So for this one, for example, I'll show you how to create a highly available, highly resilient cluster. So I'll let me first go back here because I'm going to steal, go back here. I'm going to steal the name. One of my colleagues is also creating this while I'm doing this demo. Let me go back here, add cluster, EC2, and then I'm going to name this cluster HA. So this is going to be highly available. Well, I'll do AWS HA just for to keep everything similar. So this is going to be a highly available cluster. So I can create a node pool with a specific template. So if I want to create, let's say you would do a single node cluster, which the other clusters are. You would, for example, give those VMs a name. I like to put a hyphen behind it because then it appends the number of the VM behind it, right? Or else it just be single and then one, which to me is strange. But you would give it a name, select a VM count, select a template, and then you would give it, for example, all roles. If I go down and then perhaps select a Kubernetes version, or just use the latest, if I want to select a specific network plugin, if I want to enable a project network isolation, which automatically isolates any project from other projects, so it's a logical separation between the projects, but it does that automatically for you if you choose Cano. If you want to choose another type of network provider, for example, if you want to deploy something else, you can also just edit this as YAML and then basically edit this cluster configuration as code. And then instead of using Flannel or whatever one you choose, you would just leave this out, deploy your cluster, and then just deploy your whatever network plugin you want to use in the way that is prescribed by that vendor. So you would just get a cluster without a network plugin deployed. So you then just use your kubectl command to deploy the manifests for that cluster. So I'll just go back to edit as form because I'm not going to do that. Go in, I'm not even changing anything here. Then I would hit create, and this would create a single node cluster for me, which has the control plane, etcd, and the worker. But I want to create an HA cluster right now. So I'm going to do etcd and then give that tree, because etcd of course does the raft and consensus algorithm, so it does leader election and needs to reach a quorum. So I'm going to give it tree because you need an uneven amount. I'll give it 2 CPU 4 gigs. Of course, for the database you would probably want a bit more, but for a small cluster this is enough. If not, I would definitely go with 2 CPU 8 gigs, for example, just to be safe. But I'll just choose this one. I'll only select etcd, and then I'll add other node pools, right? So I have etcd, but I also want my control plane, and this one does not do leader election, so it's active passive, so I only need 2. So select control plane, and then here I'll do the worker, and then for this one I'll just choose 3, select worker, and as you can see, so I have 3 node pools, etcd, control plane, worker, 3 VMs, 2 VMs, 3 VMs. This one has 2 CPU 4 gigs, the control plane also, and then this one, for example, I'll give more resources, so 8 CPU, 32 gigs. You could set the auto replace if you'd like. I'm not going to do that, so I'll leave it out for now. I'll scroll down, I'll just leave the latest Kubernetes version, 1.18.6, not changing anything here either, and I'll just click create. So now this is going to create a highly resilient, highly available cluster for me. As you can see, it's 8 nodes, where my other clusters, for example, this one or the other 3, are just single node clusters. So if I go to this, for example, you'll see that my nodes, I just have a single node with its public IP, private IP. I can get some information from here as well. It also points me to Grafana if I want to see node metrics. But then if I go to my high available cluster, which is still spinning up, of course, I can already see I've got my control plane, etcd, and workers being deployed. And of course, you can edit all of this stuff afterwards, right? So if, for example, this EC2 cluster or not even, because I have my own, I'll just take this cluster. It's one node right now, and I can just go in. You'll see I can edit the cluster. I can rotate all of the certificates for that cluster. I can create a snapshot of etcd. I can restore the snapshot easily from here as well. So by default, it sets an interval to create snapshots. So if you don't change it, it will set an interval for you. And you can just select your snapshot and then restore to whatever you'd like. Going back here, you can also save this cluster as an RKE template, which I will get into after this. What's also great is that you can also run CIS scans, right? So you can run a set of benchmarks that have been created by the Center of Internet Security, and then you can make sure that your cluster is just compliant to the CIS, basically, to that CIS benchmark. And you can set this to a schedule as well, so periodically it could make that scan. It can do that scan for you. So you will get automatically notified because you can attach a notifier to it if something has changed in the cluster that basically removes the compliance to that CIS standard. But what I want to show you is the edit. So if I go in, so basically for any Cloud VM, vSphere as well, so those node drivers, you can go in and edit and just easily add in new nodes. So if I want to, for example, add in more workers to this cluster, I'll just add a new node pool, or I just increase this node count, right? So, but if I just want to add an extra worker to this one, I can just go in, add an extra worker. I'll just do worker. I'll just do a small one, for example, here, and then scroll down. You can, of course, if this were to be an older version of Kubernetes, this is also where you would be able to select a newer version of Kubernetes, and it will then do a zero downtime upgrade for you. If you have any more questions about that zero downtime upgrade, just let me know in the session afterwards, because, well, there's no time to jump in it right now. Plus, I haven't created a cluster with an older version, so it's kind of my own fault. So if I scroll down, as you can see, you can just edit all of these things, right? So this is the, for example, if you did set that CIS scan interval, you could change it here, and so all of those things, right? If you want to back them up to an S3 compatible bucket, for example, you can just back up those etcd snapshots as well. But yeah, so going down, just hit save, and then now my single node cluster is going to get an extra node available. And that is all I have to do to edit that, right? So if you use any of these, then it's easy to just increase the size of your cluster like that. If you use a custom cluster, all you would have to do is this custom cluster generates a Docker run command. You can just paste wherever you want. All you go in is you edit your cluster. I don't think there's a custom one in here right now. No, you could just go in, edit the cluster, and then just copy that Docker run command again, select a role, and then paste it in your machine, and it will create one. Like, I can actually just show you as well. So if I, for example, do a test custom cluster and I go next, this is the Docker command I'm talking about. It's always easier to just show you. And this is why this is for if there are any existing nodes, right? So for bare metal or anything that you just want to, well, maybe manually or add this to some script so it does it for you. But you would just select your role, copy this command, run it on that machine or VM, and then Rancher is going to provision either a full-blown Kubernetes cluster for you, or maybe, well, you would start off with, for example, maybe just the control plane and etcd, and then afterwards you would perhaps just have the worker. But if I close this, you'll see that this is just going to stay waiting, because it's going to wait for me to paste it somewhere. But if I go in and edit, you'll see if I scroll down, I have that command again. So if I want to increase the size of this cluster, all I do is just go in. It's already set to worker because usually you're just going to be adding another worker, copy it, paste it somewhere. It could even be your laptop. Wherever you paste this, it's going to use that node and attach it to this existing custom cluster. So very powerful for if you're using bare metal, for example. I'll just delete it because I'm not going to use it. So going back here, let's see what's happening. Yeah, this is just still busy. That's why it's giving us the node not active yet. But yeah, so our cluster is this one. So this one is still busy. This one is changing. Like you see with all of these clusters, whether it's using Azure Compute or you're using vSphere, all of this is exactly the same. So you don't have to learn different consoles. They're all the same. Of course, the infrastructure is different, but the way you use it should basically just be, you don't have to know that it's running on vSphere or what's happening there, or that's not necessary. Of course, you can go a lot deeper into using specific things, like if you're in the cloud if you're in the cloud that you want to, for example, provision EBS volumes when you create a PVC and things like that. So a bit of knowledge of the underlying infrastructure is useful, but even if you don't, it doesn't matter, because you will be able to use these clusters if they are set up for you in exactly the same way. And going back to that, you can have, for example, you could still have the freedom to create clusters without actually having to know how to configure a cluster. Like I showed you with this cluster, if you go in and for example, one of these clusters that I've created, I'll create a RKE template. And from this template, I can see one of my colleagues is doing something in the background. From this template, I could, for example, give it a name and save this cluster as is. But if I go to RKE templates, you can see that from here, I can also just create those templates. So if I do add template, I can give it a name, give it a revision name, and then basically the same choices you make during the cluster creation, Kubernetes version, and any of these configuration, port ranges, that schedule, for example, all of these things you can create, or they are created for you. And then let's say that you create a cluster, and then the only thing that your end user might be able to change is the Kubernetes version, or and if they want project net for isolation and things like that, right? So sorry, like this. So if you were to create this template, you can select and configure it, and then basically say, hey, is this user going to be allowed to change these things? And if you create this template, then depending on the permissions of the users, they might only be able to use these cluster templates. However, even if you just use that, the cluster itself, when you create the cluster, you'll go in, you won't have permission to, for example, change this. It will force you to use a cluster template, and you'll be able to choose the template that is available to you. For example, I've got this vSphere one, but here you can see that I could select this template, and then I can't select and change anything else. So if I were able to perhaps choose Kubernetes version, then this would be my only option. Or if I, like you saw, I could perhaps choose to be false or true, then those are the choices that I have. But as you can see with this one, I don't have any choice, but I can create a cluster myself. So as an admin, I can give my users cluster templates they can use to just go in and create their own clusters. So as a DevOps team, for example, they have the freedom of creating a cluster when they need a cluster, right? So if I just want to quickly create a new cluster because I'm testing this or doing that, I can, right? Nobody's stopping me from creating the cluster because I just have certain permissions that allow me to use certain templates with certain node templates. And then in the cloud, I have certain resources available to me. So I can just use that. So nobody's stopping me, if at least, of course, you are allowed to use those resources. So you don't have to go to your admin team to ask for them to create a cluster. And on the other side, your admin team does not have to go and make clusters for people, because they just have the templates available, they set up the correct permissions, set up the correct resources, and then the users have the freedom, you're not seeing my air quotes, but the freedom to then still go ahead and create their clusters. So I have been talking for a while now already. So let me just quickly show you the usage of a cluster as well, right? So if I go into, well, let me take a cluster that is already finished. I can go in, I can select a project. I might only have access to a project, by the way. Here you would have your resources, so all of your deployments would be running in here. Any ingresses, any services, any volumes, but also if you want to do things like create horizontal pod auto scaling rules, use our lightweight Jenkins pipeline tool. If you want to deploy Istio from here, but also things like create config maps or secrets, for example, any certificates, registry credentials, all you can do from the UI as well. Of course, with secrets, these are just base64 encoded config maps, basically. So they're either decoded in the container or the means to decode is inside of the container. So of course, there are better solutions. For example, HashiCorp's Vault to be used when you do want to keep your secrets safer. In here, I can go in and deploy applications. Those applications are just Helm charts. And from here, you can do things like, well, just deploy any application that is available to you as an end user, because you could have maybe a specific internal Helm chart repository available to you, or you maybe have access to your own Helm chart repository for creating your own applications. But any catalog that you have available, or you can add in here, these will then be used to then have applications available when you try to deploy an application. So if you want to do something like deploy the Vault operator, you can just do it from here. If you have a subscription, or if you have a paid subscription to a specific application and they have some private Helm repo, you just add that private Helm repo in here and then add in your credentials if necessary. Then you can just deploy it from within Rancher as you would any other application, which is of course a lot better than, well, at least it's a lot more managed than going in and deploying your own image and selecting your whatever you want to configure in Kubernetes and then launching that single image. So Rancher is just your single pane of glass for any clusters that you have out there, right? So whenever you have a bunch of clusters that you need to manage, just import them into Rancher. You've set up your central authentication. If you have set up your central authentication, the users that are available will then get certain roles. These roles can be global on a cluster level or on a project level. You can create your own roles. So you can go very far in defining certain permissions for your users and then add them to clusters, add them to projects. Basically, you have full control over who has access to what. This is it, guys. I don't have any time left. So if you have any other questions, please ask us in the session afterwards. There's so much more I could talk about, but I only have a certain amount of time. So please, any questions, let me know afterwards and I'll be happy to help you out. Thanks for watching and I'll see you in the live session.